Welcome to LMS Solution. Today we are going to see about comparison of Grey Wolf MPPT, Fuzzy MPPT and PO MPPT for solar PV system with the partial shading effect. This is the Simulink model created for testing of comparison of Grey Wolf, Fuzzy and PO MPPT for the solar PV system with the partial shading effect. Here we have 4 cells, that means a 4 panel connected in series in order to create that partial shading effect concept. Each panel, the rating is 249 watts, and then the voltage at maximum power point is 30.96 and current at maximum power point is 8.07. The 4 panel connected in series, the maximum power obtained from this panel is around 1000 watts under standard test condition. That means under 1000 watts per meter square under 25 degrees Celsius. Here we are providing the different irradiation for the each panel not to create the partial shading effect. And this is nothing but a Grey Wolf optimization MPPT. When we receive 2 inputs, EPV, IPD, and it will be generate duty cycle. And this is known as boost converter. This boost converter is connected in between this PV panel and the load resistor. The duty cycle from this GWO MPPT is processed via PWM generator. This PWM generator generates the pulse for this IGBT in order to extract the maximum power based upon that partial shading effect. Next you have to see PO MPPT for solar PV system with the partial shading effect. So this is a model created for a PO MPPT for solar PV system under partial shading effect. Here we are using PO MPPT which receive 2 inputs, voltage and current. Based upon voltage and current, it will generate duty cycle. Next you have to see the Simulink model for Fuzzy MPPT. This is a Simulink model for a Fuzzy MPPT. So the Fuzzy MPPT will receive 2 inputs, VPV, IPV, and it will generate a duty cycle. You can see inside the block of the Fuzzy MPPT. This is a block, Simulink block. Here we need to calculate change in power, change in voltage, and then you have to calculate error, change of error. Based upon error, change of error, the fuzzy logic will be generate the duty cycle. Next time you have to explain the GWO code. This is a GWO code, that means GWO MPPT code. Here you can see that we implement the GWO. Based upon this, the GWO code, it will generate it will find the optimal duty cycle in order to get the maximum power from the PV panel. This is a code used for GWO MPPT. Next time I'm going to open the PO MPPT. So this is a code for PO MPPT. Based upon change in power and change in voltage, here the duty cycle is going to be decrement or increment based upon this condition. The detail about GWO MPPT and PO MPPT I explained in my early video. You can check my YouTube channel in order to get the better detail. Now I'm going to test the system for the 4 condition. First I'm going to test the system with the uniform irradiation. That means I'm going to make 4 panel irradiation equal to 1000. And then I'm going to simulate the model. Same condition I'm going to consider for PO MPPT and Fuzzy MPPT also. Here I'm going to change 1000, and then we are also meant to make to change to 1000. Now I'm going to simulate the PO MPPT and the Fuzzy MPPT Simulink model, and then we are going to check that means you are going to compare the power extraction detail. Here you can see that under uniform irradiation at 1000 watts per meter square, the GWO MPPT reach maximum point around 1.2 seconds. And also you can see that the rise time is very less when compared to PO. Here you can see that Fuzzy MPPT, the Fuzzy MPPT rise time is more or less same as a GWO. We need to wait for the final steady state point. Here you can see that the PO MPPT, it reached this point, but you can see that it's not reach the maximum power point. They have some deviation in the maximum power point under uniform irradiation condition. And also here you can check the Fuzzy MPPT. So Fuzzy MPPT is not able to track the maximum point, is trapped at the local maximum point. We'll wait for the response of Fuzzy MPPT. Here you can see that after some time it trapped in the local maximum point. After that it reached to the global point. When comparing the result of GWO and then PO and Fuzzy, and the GWO will be having the smooth response, and also it would reach the maximum point very quickly. But PO and fuzzy having high rise time, and also it trapped into the local maximum point for this uniform irradiation condition. Next, I'm going to simulate the model with making the irradiation equal to 1000, 1000, 1000 and 300, and then I'm going to check the result of the GWO, PO and Fuzzy MPPT. Now I'm going to simulate the model one by one and we'll check the results. Here you can see that the GWO is reached the maximum or global point very quickly, but you can see that PO will is taking long time to reach the global maximum point. But you can see that fuzzy having the similar response with the GWO, but we need to check the maximum power point. For that, I'm going to click this one. I have to check the maximum power point. You can see that we are getting 742 watts by using GW. Here you can see that we are getting only 729 watts by using PO MPPT are getting around 738 watts, but you can see that we are not getting the maximum point. That means by using Fuzzy MPPT, we need to check the results. We have to wait for some time. The simulation is going on. Here you can see that the Fuzzy MPPT will provide only 723 watts. So when comparing this three results, the GW MPPT will provide the maximum point than PO and Fuzzy MPPT for this particular condition. So next I'm going to compile result for the next operating point. That means I'm going to make the irradiation equal to 1000, 1500, 300. Here also I'm going to change to 500. Here also I'm going to change to 500. Now I'm going to simulate the model and then you have to check the results of the maximum power point tracking of GWO, PO and Fuzzy. First you have to check about the rise time. Here you can see that GW reach the maximum point and P also reach a maximum point, but they have some difference. GW having less rise time, PO having more rise time than GWO, but the rise time of GWO and Fuzzy will be same. Here you can see that there is small change in that the power extraction from the PV panel. So here you can see that GW already reached a maximum point. So now I'm going to check the power from the GW MPPT. That means power extraction from the GW MPPT and PO MPPT and Fuzzy MPPT. Here you can see that the maximum power from the GW MPPT is around 486 watts. Here you can see that PO having 485 watts and then Fuzzy having only 424 watts. So Fuzzy not able to track the global maximum power point because we need to tighten the rules, Fuzzy inference rules. Then only we can easily get the maximum or global maximum point from the PV panel. From this comparison also, the GW MPPT work better than PO and Fuzzy MPPT. This is a comparison of the GW MPPT, PO MPPT and Fuzzy MPPT for the solar PV system under partial sharing effect. For three operating condition like uniform irradiation and partial shading condition, the GW MPPT provide better result than PO MPPT and Fuzzy MPPT. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.